On today's edition of Kicked Up Chemistry with Professor Leonard, the reactions are very dangerous, so do not try these at home. You can be very seriously burned, maimed, or killed if you don't know what you're doing. So I've done these plenty of times. I know what I'm doing, so please do not try to reproduce these reactions at home. This is 25 grams of Thermite. Okay, we're at Thermite day 2. We had some issues yesterday in which these little dollar store sparklers weren't enough to light the Thermite. So I had to get some larger ones that are actually made for lighting Thermite. Also, the 25 grams of Thermite barely was enough to come up to where the sparkler is to ignite it. So I'm actually using 50 grams. So I have twice as much in there as recommended, just because it won't actually go all the way up to the sparkler, and I want to make sure that it lights because I only have a couple of these large Thermite ignition sticks. Again, there is the sand down there, so that way we can collect our iron that hopefully should run out of the bottom of the flower pots. This is 25 grams of Thermite. Now I'm going to put an empty container on here so we know how much the empty container has a mass of. And it weighs 1.6 ounces. So let's round it down, 1.5. So basically then we'll subtract the weight of that off. This is a little over 8 pounds of Thermite. It's actually 8 pounds, 13.2 ounces, but remember we have to subtract those 6 ounces off from the empty container. So this is just about 8.5 pounds of Thermite. All right, so the Thermite reaction is the reaction between powdered aluminum and iron 3 oxide. Most people think of iron 3 oxide as rust, and it's the reddish color. Well, that's actually 3 different types of iron 3 oxide, depending on how many water molecules get trapped in its crystalline structure as it's being made. Now, Fe2O3 pure iron 3 oxide is actually black. If a small amount of water gets trapped in its crystalline structure, usually 2 molecules per every formula unit of Fe2O3, it's actually yellow. When it's fully hydrated, 5 to 6, 7 water molecules trapped in that crystalline structure, so it's a fully hydrated complex, then it's red like rust is that most people are familiar with. So for Thermite to work properly the best, you actually need black iron 3 oxide, so the anhydrous iron 3 oxide. This would be called a redox reaction, or oxidation reduction, because we have a transfer of electrons. The aluminum over here has an oxidation number right now of 0. Anything in its standard state is 0. Over on this side, however, it has a charge of +3. So it has lost 3 electrons, or transferred them rather, from the aluminum to the iron, and it's an oxidation reaction because typically you have oxygen involved in an oxidation reaction. So the aluminum starts out over here as being neutral, 13 protons, 13 electrons, and it's going to then lose 3 electrons, so it becomes a 3 positive charge. All right, so the reaction that we did already involved 50 grams of thermite. Even though I was going to do 25 grams, I had problems with having enough thermite coming up onto the big sparkler in order to actually get it to light. Now we're going to see if we can do all 8 pounds of our thermite. So let's convert pounds into grams. We have a factor label conversion here. We have pounds on top, pounds on the bottom, so they'll cancel out. And there are 453.6 grams in a pound, which gives us 3,628.8 grams. Now, to figure out how many times that is that we used from what we should have used our 25, let's divide that by 25 grams, and we get 145 times more thermite in our 8 pounds than our 25 pounds. Now, if we actually wanted to see how much really that was, because that was 50 grams, that would be 72.58 times the amount. So still a big step up from the 50 grams. Okay, now here is the sand that I had the thermite go into. I haven't touched it at all yet. Here is the flower pot. Again, I always put 2 flower pots together because one always seems like it breaks. So we got quite a bit of molten iron in here. When that reaction happens, it gets so hot that the iron is actually molten iron that comes out of the bottom of the flower pot. Here we can see the bottom of the flower pot where it has broken free from it. And there's a chunk of iron right there. Now we can tell that it's iron because I have a magnet. And it most definitely is magnetic. So it's pretty easy to identify that that is iron. So our rust has turned back into iron. And part of this here, not quite as magnetic, it's kind of a different color. This is actually the stick that the sparkler was attached to, the metal portion of that. So the stick from the sparkler melted in here as well. So now let's see what happens when we step up this reaction about 75 times. Alright, so what I've done is I took a flower pot, I took one of those thermite ignition sticks and just made a little base for it and duct taped it to the bottom of my flower pot. And obviously if I put the thermite directly in there with the hole, then it would all run out. So I had to cover it with some duct tape. So I'm going to zero out the scale here. So we'll hit tare. So that'll cancel out the weight of the flower pot. And we'll start adding our thermite to it. So I don't know if I'll be able to fit all 8 pounds in this flower pot. It's the biggest one that I had. So there we're up to 2.4 pounds. We'll keep going until we're all the way up to the top. And I'll shake it down. And that's about all that I can fit in this flower pot, which is quite a bit. So it is all the way up to the top, and we have 4 pounds, 2.6 ounces. So that's about the most thermite that I've ever done at one time. I can't fit 8 pounds in this flower pot, so I think what we'll do is we'll go ahead and do 4 pounds and see how it turns out, and then maybe in another video we'll do the entire 8 pounds of it, depending on how this goes. Okay, well, I've got the 4 pounds of thermite. I lined the plastic container with metal pans also and used a whole lot of sand. Wet the sand down also in the whole area around it, so that way it prevents anything from catching on fire. So let's see what happens. All right, now that I got the plastic fire put out, we can see the aftermath of it. You can see it's still very, very hot. There's the molten iron. There's molten iron down there, and the flower pot pretty much destroyed, along with my pan underneath, it looks like. Well, thanks for watching. I hope that you enjoyed today's version of Kicked Up Chemistry with Professor Leonard. As we can see, Thermite definitely is an outside toy. You would never want to do that inside, and don't try to recreate any of the experiments that were done in this video today, because as you can see, it could be very, very dangerous if you don't know what you're doing. So if you could, click that like button, that subscribe button also, so that way you'll get notified when there's more cool videos like, oops, I used too much Thermite. Thanks for watching.